Hi, my name is Javier García Guzmán, professor at the Carlos III University of Madrid. I invite you all to travel with me this week to see how software architects are creating smart information systems. We are going to illustrate the process of designing software architectures using examples from smart cities. These systems require the creation, reuse, and orchestration of different pieces named components. They can be user interfaces, services from the cloud, smart things, open data sources, and pieces that facilitate a seamless coordination among them. During this lecture, we are going to identify the different types of pieces that a software architect has to consider when designing a software solution. Who is in? Are you ready? Here we go. Let's see an example from a smart city. As we don't have much time, we have contacted the head of the Department of Software Architecture in Madrid City Council. To illustrate how the apps for digital smart cities are, my colleague presents a service for planning and managing routes in the city using public transport, considering the mobility restrictions of a citizen. People having mobility difficulties often use public transport for their daily activities. However, these people have problems when there are unexpected changes to the architectural infrastructure which create physical barriers for them. The app helps people with temporary or permanent motor disabilities to properly plan their journeys around the city, bearing in mind the profile of the users and their preferred means of transport. Real-time accessibility of the different means of public transport and their status with regards to incidents or issues that temporarily change their accessibility. Other issues, reporting incidents regarding public transport, supply information on changes to accessibility in real time. Do you want to know how to design apps for digital smart cities like this? Follow me. Software architecture design refers to the process of defining and identifying the pieces that are necessary to create a software solution. Let's see what are the most relevant elements to consider in the design of a software architecture. Advanced software systems are composed of two types of software pieces: front-end and back-end elements. Front-end elements supply end users with the interface to interact with the functionalities of the software system. In the app for managing accessible public transport trips, front-end components are the different interfaces that a citizen can use to interact with the system. For example, tablets, mobile phones, eyeglasses, or wall screens. Front-end elements should provide ubiquitous access. Ubiquitous computing is a concept where information access is designed to appear anytime and everywhere using any device, any location, and any format. Front-end elements should be adapted to the user's devices and characteristics, providing specific features to address the user's personal attributes, such as the tasks to perform while they are using the system and their sensitive or cognitive characteristics. Front-end elements should also be adapted to environmental conditions, where the users interact with the system, because these conditions could lead to different alternatives due to connectivity, processing, and information access. A more detailed view of how to design the front-end elements is discussed in the Creativity and Participatory Design Weeks. Back-end elements are a set of components that are in charge of receiving the requests from the front-end elements and sending the raw data to them in order to provide the information required. This refers to everything the user can't see in the user interface, like sensors, actuators, data sources, services, and servers. The back-end elements can be classified as controllers that are in charge of receiving requests from the users, identifying the specialists that can help to respond to the requests, choreograph the intervention from these specialists, and prepare the information to be sent back to the front-end elements. Specialists are components that have a specific responsibility. A software architecture can have several types of specialists, such as business logic components are in charge of implementing specific calculations or taking decisions that require the knowledge of a specific problem and its solution. In the Accessible Transport app, a component that is able to calculate underground routes between two stations is an example of a business logic component. Smart things are objects with embedded electronics and software elements that can provide information of the actual state of the object and can change how they are performing. These kind of components are used to create a more direct integration between the physical world and the computer-based systems. In the Accessible Transport app, a smart thing can be an elevator that sends information regarding if it's out of front or not. This information can be considered to determine the most appropriate trip for a specific citizen. A data connector is a component whose main goal consists of retrieving and upgrading the information required for a specific functionality. The data is typically organized to model aspects of reality that support processes requiring information, such as modeling the accessibility of subway stations to help find the most appropriate route for a person with a physical disability. In this video, we have seen that the main purpose of software design is to define and specify the architecture of components required to satisfy user needs. We have also discussed the two main parts of a software architecture, front-end and back-end elements. For each of these, we have discussed their main characteristics and elements. In the coming videos, we will be introducing and analyzing how to design the components presented in this lesson. Be very careful, because if we do apply the effective software design elements and principles, we will be one step ahead of the creation of the software of the future.